Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is max points, which is a medium level problem. So the problem says that we have been given a 2D integer array ranges of size n, where the ith item is denoted by a vector of size 3, right? So the first element of the ith item would be start of i, the second item would be end of I, and the third item would be coins of I, right? So these are some ranges starting from start and ending till end, and a number of coins are associated with it. Now we have to consider all these ranges, and we have to find the maximum number of points we can get, right? So how can we select the ranges? We can select at most two intervals so that they do not intersect or overlap, but they can touch each other, right? So this is a condition that these particular ranges should not intersect or overlap, but they can touch each other, and we can select at most two such ranges such that the number of coins or in those two ranges are maximum. By maximum, I mean when you take the summation, that summation should be maximum. So let us take this particular example where the answer is coming out to be 7. So here the ranges are 1 to 3. The first range is from 1 to 3 and the value is 4. The second range is from 2 to 3 and the value is 5. The third range is from 3 to 4 and the value is 2. Now let's suppose that you take this particular range. Since you have taken the range 2 to 3, so let's say this is 2, this is 3. Now you would observe that the value of the first range is greater than the value of the last range. But since the range 1 to 3 would be something like this, these two ranges are overlapping, so we cannot take this particular range. Now the last range is from 3 to 4, so it is actually like this, 3 to 4, and its value is 2. So since these are just touching on their ends, we can take this particular range, but they should not overlap like this. This is totally valid that they touch each other, right? So the total cost that we can get is 5 plus 2, and that is equals to 7. So 7 will be our answer, right? So like this would be like the explanation of this particular problem. You just have to make sure that you can just take those ranges which touch each other, but you cannot take those ranges that overlap each other or intersect each other. So how can we solve this problem? First of all, let us discuss some very simple brute force approach. What you could do is, so you can just run two for loops. The first for loop is from 0 to n. The second for loop can also be from 0 to n, but you can also take it from I plus 1 to n, right? So you will get two values I and j. You can check, first of all, you can check whether I and j are compatible or not. By compatible, I mean that they should not overlap, neither they should intersect, right? They should be independent ranges. So if they are compatible, we can update our answer as answer is equals to max of answer comma C of I, let me just write it, cost of I plus cost of j, right? So this would be the final answer. Your final answer will be stored in the answer variable. You can take the maximum of all these values, but since it is an n square loop, the total time complexity will be n square, because there are two for loops nested inside each other. So this is obviously not valid and will get TLE according to the constraints that we have been given in this particular problem. Now what can we do to solve this particular problem? So you would observe that the values that have been given to us are in this particular format. This is the starting time, this is the ending time or ending point, you can say E1, and the cost associated with it, C1. So then we have S2, E2 and C2. Then we have S3, E3 and C3. And we have S4, E4 and C4. Right. So if we sort all these values according to S and E, right, so the smallest starting time comes first and also the smallest ending time comes first, right? So the first priority will be with starting time and the second priority will be with ending time. Since we have all the values sorted according to started time, you will see that for example, if I have some S2 and E2 here, so for this particular ending time, if I choose a starting time SI, let's say, so we know that this particular value should be greater than or equals to this particular ending time, right? This is a constraint. So we already know that the ending time would definitely be greater than or equals to S2, right? So any Si which is also greater than or equals to E2 will definitely lie to the right side of it in this particular range after this particular element E2, right? Since ending time or ending range will always be greater than the S2, E2 will always be greater than or equals to S2. So Si, which should be greater than or equals to E2, should lie in this particular range. Now, so let me just write it in an equation so that you understand it better. So Si is greater than or equals to E2 and E2 is greater than or equals to S2. Right. So this particular Si should always lie in this particular range. So what I can do is I can just traverse through all of this range, right, and just check for all values Si which is greater than or equals to E2. I'll consider this particular range as my answer. So for example, S3 is greater than or equals to E2. I can take the final answer as C2 plus C3. So this is one of my possible candidates. Then again, C4, C2 plus C4 can also be a possible answer. So I have to take the maximum of these. But you see, the problem with this particular approach is that we are still running an n square loop in the worst case. So now we know that we have to search in this particular range, but it is of no use because we'll still have to traverse the whole loop. Right. So what do we do to improve this particular idea? The one thing that we can do is, since we already know that these values S1, S2, S3 are already in sorted order, since they have been arranged in increasing order. So we can apply binary search to find the smallest value Si such that it is greater than or equals to E2. E2, in this case we are considering E2, but we will have to traverse through all the values. So it will be in general case Ej, right? So Si should be greater than or equals to Ej. This way we will be able to take two pairs. Now to find the smallest index I, we can apply binary search. Now for example, like S3, let's say S3 was the smallest index, or 3 was the smallest index at which Si was greater than or equals to E2. Still we will have to take the maximum among all these values. Why among all these values? If S3 is greater than or equals to E2, then S4 will also be greater than or equals to E2. Why? Again, because of the same fact that they are all arranged in increasing order. So all these values C3, C4, C5, if there is a C5, and so on up to C of n, right? So all these values will be a candidate for our possible answer. We'll have to check for all these values, right? So again, we'll have to run a loop to check for all these values, right? So we need to find some way to answer it in O of one time. This particular query, that what is the maximum starting from Ci till Cn. So we can easily do it using a postfix vector. How? We will store the postfix vector. The post vector at ith position will store the maximum element among the positions Ci, comma, Ci plus 1 and so on up to Cn, right? So if this postfix vector stores the maximum among all these values, then we have improved our overall solution to n log n. I'll explain you how it is n log n. So first of all, we'll traverse through all the values to find a suitable Ej. So for example, we have found E2. Now if we have found E2, let's say j is equals to 2. If we have found E2, now we have to find an I, index I, such that S of I is greater than or equals to E2. So let's suppose that we have found our I is equals to 3. Now all the values after this particular index C3, C4, C5 and so on up to Cn are possible candidates for our answer, right? So we need the maximum value among all these values. Why all of these are possible candidates for our answer? Because if S3 is greater than E2, then S4 will always be greater than or equals to E2. Similarly, S5 will always be greater than or equals to E2, right? So this continues. Now we have to find the maximum values among these. So we can answer this particular query in O of one time if we store all the maximums in a postfix vector, right? So the traversing part is O of n, right? We traverse through all the values. The binary search part is log n, and since we are answering the maximum answer query in one time, so it is O of 1, right? So that is why overall it is n log n. So this was the whole approach about this particular problem. Now let me just quickly summarize what I just said. So I believe you are already clear how do we have to take the ranges. We don't have to consider these overlapping segments, but we can consider two ranges if they are just touching each other, right? So that means the starting, if we are taking two ranges, the starting range of let's say the jth range should be greater than or equals to the ending part of the ith range, right? So this is our main condition. Now we can solve this particular problem with brute force by just making two for loops, and we will get two ranges to consider I and j. If there are valid ranges, that means they do not overset or they do not overlap, then we can take those ranges and consider the ci plus cj as a possible candidate answer. So we'll take the maximum of the current answer and ci plus cj, right? So this is obviously not going to work because this is an n square solution. How do we improvise on this solution? After sorting this whole array according to S and E, right? So the first priority will be to sort according to the starting part, and the second priority will be to sort according to the ending range. Now once we have sorted according to this, we will observe that if we choose any j, for example, if I have taken j to be 2, j is equal to 2. So if I consider ej, in this case it would be e2. Now if I want to find the next range, it will always lie to the right of it, right? So how do I effectively find the smallest index I such that s of I is greater than or equals to e2, or s of I is greater than or equals to ej? Since all the values of s are sorted in increasing order, I can easily apply binary search on it to find the smallest such index. Once I have found the smallest such index, so for example, let us take I to be 3 such that s3 is greater than or equals to e2. Right. So if S3 is greater than or equals to E2, we know that S4 is greater than or equals to S3. So it always be greater than or equals to E2. Similarly, I can write S5 here also, and also Sn. Right. So I have to consider the maximum value of the cost among all these values, since all these S are greater than or equals to E2. So I have to consider the maximum value of C, or the maximum value of cost among all these values. So I can answer this particular query effectively if I use a postfix array, where post of I will denote the maximum value among ci plus 1, ci plus 2 and up to ci, right? So this would be the overall solution with the help of which I can find my answer. So for each j, once I have found that I, so I can easily answer the post of I query. So my final answer would be c of j plus the element stored at post of I. Right. So this would be one of my candidate answers, and easily I can take the maximum of answer comma this particular value. Right. So this is how I compute my answer. So answer will be updated like this. So let me just show you the code now for this particular problem. So what I have done is I have initially sorted all the ranges. So this is the ranges dot begin and ranges dot end. And if the first element is equals, that is that in that particular case I just return a1 is less than b1, that is the ending range is smaller than the ending range of the second part. So the ending range are also sorted in increasing order. Similarly, if the first element is not equal, I just sorted in increasing order. Now I just create a postfix vector. So post of n minus 1, since I am taking 0 based indexing, what I'll do is I'll just set post of n minus 1 is equal to ranges of n minus 1. So at that second location, the cost is stored. So that is why I'm taking the second position. Now starting from n minus 2 till I is greater than minus 1, I just do post of I is equals to max of post of I plus 1, comma ranges of I plus 2, I and 2. So this is basically like simple postfix vector that you must know. Right. So now I initialize my answer with 0. So for each index starting from 0 till less than n, I initialize two variables, low and edge. So this is just for binary search, and I'm using a technique called invariance technique. And in this particular technique, here I'm assuming that the highest edge, that the edge value will always be true and the low value will always be false. Why? Let me explain you how. L is equals to I. So I will always be false because I know I need some index greater than I, right? Definitely I cannot be taken again. So I need some index greater than I. So that is why I will always be false. Now why h is equals to n will always be true? The position n will always be true because if there are no positions that are no ranges that are satisfying my condition, then n, which is just out of bounds, since we have positions only till n minus 1, L will always satisfy, right? Because there is no range after it. So what I'll do is I'll just run a loop while low is less than h minus 1. I calculate my mid. Now if range is mid, so this is the starting part, ranges of mid comma 0. So this is s, and this is the current ending point. Ranges of I comma 1 is good. If this part is greater than equals to the current ending point, then I'll assign high to mid, because now this is a valid answer. So h is always true. That is why I assign mid to h, and since low is always false, If this is not satisfied, low is mid is assigned to low. Now at the end, I know that h will always contain my answer because it is always true. Now I initialize my current variable with 0. Now if h is less than n, that means h is a valid range value. I update my current value as post of h so that I can take the maximum. Now I can update my answer as maximum of answer comma ranges of 5 comma 2 plus the current value. Right, so this would be the maximum value for all C1, so for all Cj, Cj plus 1, Cj plus 2 and so on up to Cn. Right. So at the end, after I'm out of this for loop, I can just return my answer value. So this would be the solution of today's problem of the day, max points. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video. And don't forget to subscribe to this channel. It's always free of cost and you can always unsubscribe if you don't find the videos interesting later. So I see a lot of people who watch these videos have not subscribed yet. So if you are one of them, please do consider subscribing to this channel. Share this channel with your friends. Until the next video drops, keep coding, stay safe, bye bye.